So our problem says that a spring has a natural length of 20 centimeters. If 25 newtons of force is required to keep it stretched to the length of 30 centimeters, how much work is required to stretch it from 20 to 28 centimeters? So first, I always like to just pick out the numbers in these word problems because more likely than not, you're going to use them. So the natural length is 20 centimeters. From the natural length to 30 centimeters, it takes 25 newtons of force to stretch it. And then we're trying to find how much work is required to stretch the spring from 20 centimeters to 28 centimeters. Also, come in handy in this problem are these equations right here. This is Hooke's constant, and it says that force is equal to K, a constant, times x, and the work is equal to the integral of this. So obviously we're going to need to find that k, and we have all the information we need to do that. So first, we're given the force in newtons, and in terms of work, the unit is going to be in joules because it has to do with newtons and meters. So we need to convert these centimeters to meters, which fairly simple. This would be 0.30, 0.20, and 0.28. Okay, so we have our value for force, so we can go ahead and plug that in to our equation. 25 25 is equal to a constant k times this x is going to be whatever distance this spring is being stretched. So for 25, it was being stretched from 0.20 meters to 0.30 meters, and that distance is 0.10 meters. And simply solve for k, we get 250 as k. And now, to find the work, we can make up a general integral. So the work equals the integral of k, which we have now, 250 times x dx. So that's our general integral, and now we just change our upper and lower limits to suit our problem. In this case, we're trying to go from 0.20 to 0.28 centimeters, and that distance is 0.08. So we're just going to go from 0, which is the natural length, so it's 0 distance traveled, to 0.08. And it's a simple integral. We get 250 x squared over 2 from 0 to 0.08. And then this will reduce to 125 x squared. When we plug in 0, it'll be 0, so really 0.08 squared times 125, which equals 0.8 joules of work.